Hello, this is question 7 on your June 2019 paper 1 from Edexcel. It's an A-level paper, but it's a question that you can do in year 12 because it's exponential question. So in a simple model, the value V in pounds of a car depends on its age, T in years. And the following information is available. So the value when it's new is £20,000 and the value after 1 year is £16,000. Use an exponential model to form for this car a possible equation linking V with T. So this, if it's exponential, is going to look something like V is going to be equal to a constant, e to the power of another constant. I'm going to call, I think, this constant V0 because it's going to be the initial value anyway. And this constant that I have here is going to be negative because the car, I imagine you know that, but even if you don't, with these details you will know. So the value when it's new is 20,000, after a year is 16,000. So the value of the car is decreasing with time. So this constant is going to be negative because my exponential is going to go down. If you don't know or you don't notice, it doesn't matter, because if you write it positive, when you find the value, you're going to get that is a negative value. If you write a minus here, you're going to get that your constant is positive. So either way, it doesn't matter if you don't realize. Yeah. So I'm going to leave it positive, and then we will see that that k is negative. So it says when the value when it's new is £20,000. So when t is 0, V is going to be £20,000. So if I substitute here in my model, I have that when t is 0, this is going to be 1 because e to the power of 0. So V, which is £20,000, is going to be equal to V0. Yeah, that's why I say this is going to be always the initial value. So I found V0. And then I'm going to find K. And to find K, I'm going to use the other information that they tell me. So when T is 1, the value is 16,000. 16,000. So if we substitute, we have that V is 16,000. Is going to be equal to V0 that we already know. So I'm just using this, but I know V0. So it's 20,000 e to the power of k times 1 because the time is 1. Yeah. We can simplify this a bit. So 16,000 divided by 20,000 is 0.8. Is going to be e to the power of k. If we take logs, ln, not logs, is ln 0.8 is going to be k. You can, I would say you can leave k like this, or you can find it with the calculator, and then you get that is minus 0.223. You see that is negative. So even if you don't realize that this is negative, you are going to get that your k is negative. So the model, that's what they ask, is going to be 20,000 times e to the power of minus 0.223t, or if you prefer, you could leave ln 0.8t. Yeah, so this is the model, and this is what we are going to use for the rest of the question. It says the value of car A is monitored over 10-year period, and the value after 10 years is £2,000. Evaluate if your model is going to give you something similar. Yeah, so evaluate the reliability of your model in light of this information. So we are going to find what the model predicts when t is 10 and compare with that value. So when t is 10 years, V is going to be 20,000 times e to the power of minus 0.223 times 10. If you do this, you get 2,147.48 pounds, which is really close to 2,000. Yeah, mainly thinking that we are starting in 20,000. So I would say is very reliable. Yeah, it's reliable or reliable enough. Yeah. And then the following information is available for car B. It has the same initial value, and the value depreciates more slowly that of car A. Explain how you could adapt the equation found in A, so that could be used to model the value of car B. So this constant is the one telling you how fast your exponential is becoming closer to 0. You don't necessarily need to think that, but what I think you could think is the initial value here was 20,000. If it depreciates slowly, more slowly than this one, after 1 year, this value will be greater than this one. So let's say it's 18,000, just because it's greater, yeah, after 1 year. So if you go back to your model when you find K, this K is the ln of the quotient between 16,000 and 20,000. So if this number is greater, this number is going to be greater, which means the ln is going to be greater. So it's going to be closer to 0. It's less negative, if you want to say that. Yeah. So your value of K is going to be greater. So K greater, or less negative in case it's confusing. Negative, yeah. And it comes from here. I think the best way of thinking about that is just thinking that this value is greater, and this is just a guess, yeah, a guess. So this value is greater. When I divide by 20,000, this is going to be greater, so ln is going to be greater, yeah. And that's all with this question.